This is section 9.3a, Geometric Sequences and Series. A sequence is geometric if the ratios of consecutive terms are the same. Now we've already seen arithmetic sequences, and we remember that with arithmetic sequences the difference between consecutive terms is the same. Well, with a geometric sequence we're still looking at consecutive terms, but now we're dividing one by the other. We're finding the ratios. And let me just show you that in an example. Look at this sequence: 1/2, 2, 8, 32, 128, 5, 12. If I divide consecutive terms, by each term by the term before it. So each term is a numerator, the term before it is the denominator. If I look at that pattern, I can see that the common ratio is 4. Let's look at this example. 2 divided by 1/2 is 4. 8 divided by 2 is 4. 32 divided by 8 is 4. 128 divided by 32 is 4, and so on. So the common ratio R is 4. And therefore, since this sequence has a common ratio, it is considered a geometric sequence. The formula for the nth term, alright, so when you see a sub n equals something, we know that we're talking about the formula for the nth term of the sequence is 1/2 times 4 to the n minus 1. Now we're going to learn how to find the formula for the nth term later, but you should notice a couple things just right off the bat in seeing this formula that's been given to you. You can see that 1/2 is the first term. We can also see that 4 is the common ratio, and then we have n minus 1. And again, we're going to learn about how to do this, but already you should be kind of seeing a pattern that you're going to see repeated in the next couple of screens. In this sequence, the common ratio R is 3, and again, we can verify that as we did in the last screen. 12 divided by 4 is 3. 36 divided by 12 is 3. 108 divided by 36 is 3, and so on. The formula for a sub n is 4 times 3 to the n minus 1 power. And again, you should see the same pattern at work. 4 is our first term, and then 3 is our common ratio, and then I have n minus 1 as my exponent. And let's plug in some values of n just to verify. For the first term, 4, n is 1. Okay, remember that the value of a term is not the same as the number or order of the term. And just a quick run through on that. The value of the term here is 4. But the number of the term, or its order, n is 1. The value of the term here is 12, but n equals 2. Here the value of the term is 36, but n equals 3. Here it's 108, n equals 4, 324, n equals 5, 972, n equals 6. Okay, so just to keep repeating an important idea, the value of the term is not the same as its order. Alright, so for n equals 1, okay, so in this case, the very first term, n equals 1. Well, 1 minus 1 is 0, 3 to the 0 is 1, and 4 times 1 is 4, and therefore I have 4. How about term 2? Well, for term 2, which is 12, n equals 2. Putting in n equals 2 here, I get 2 minus 1, that's 1. 3 to the 1 power is 3. 4 times 3 is 12, and I have 12. How about for 36? This is the third term, so n equals 3. 3 minus 1 is 2. 3 squared is 9, and 4 times 9 is 36, and I have 36. Here is another sequence. We can see that the common ratio R is negative 1/3. Again, I just get that the same way. Negative 1/3 divided by 1 is negative 1/3. 1/9 divided by negative 1/3 is negative 1/3. Negative 1/27 divided by 1/9 is negative 1/3, and so on. And you can probably guess by now what the formula for a sub n is, what the formula for the nth term of this sequence is. So just to see if you've been recognizing a pattern, I want you to pause the video, write what you think the formula for the nth term is, and then resume when you have an answer. So you should have come up with this. The formula for a sub n, or the nth term of the sequence, is 1 times negative 1/3 to the n minus 1 power, or simply negative 1/3 to the n minus 1 power, because the 1 disappears. And notice that this follows the same exact pattern we've been seeing. We have here the first term is 1. We have here the common ratio is negative 1/3, and we have here the exponent n minus 1. So to put that in general terms, the nth term of a geometric sequence has the form a sub n equals a sub 1 times r to the n minus 1 power. And that is where r is the common ratio of consecutive terms of the sequence. How about for this sequence? 1575, 375, 1875. Well, I can see the patterns. I see that the ratio, the common ratio, is 5. And I also see that this first term here is 15. All right, so I can already fill in. My my formula. So the nth term is 15 times 5 to the n minus 1 power. And that's verified here with each term as well. So for n equals 1, the first term, well, 1 minus 1 is 0, 5 to the 0 is 1, 15 times 1 is 15. For n equals 2, 75, 2 minus 1 is 1, 5 to the 1 power is 5, 5 times 15 is 75, and 75. For n equals 3, 3 is 75. Plugging in 3 for n here, 3 minus 1 is 2. So 5 squared is 25, and 15 times 25 is 375, and so on. Write the formula for the nth term of this sequence. All right, you're capable now of doing this on your own, so pause the video, get that formula for the nth term, and then resume when you have an answer. So we write down what we know. We know that the first term is 3, and that's obvious because this is the first thing in the list. We also know that r equals 2, 6 divided by 3 is 2, 12 divided by 6 is 2, 24 divided by 12 is 2, etc. And therefore, I can write my formula. A sub n equals a sub 1 r to the n minus 1 power, and I just fill in what I've observed. 3 times 2 to the n minus 1 power. Here's another example. Find the 9th term of the geometric sequence whose first term is 7 and whose common ratio is 3. Again, pause the video, do this on your own, and resume when you have an answer. All right, so you probably figured out that the first step is to find the formula for the nth term. And so we follow the procedure that we followed on the last screen. We know the first term is 7 because that's given to us. We know that r is 3 because that's given to us. And so the formula for the nth term is a sub n equals a sub 1 times r to the n minus 1 power, and that equals, in this specific case, 7 times 3 to the n minus 1 power. All right, now that I have the formula for the nth term, I can find the value of the 9th term. And to do that, I simply plug in 9 for n. So a sub 9 equals 7 times 3 to the 9 minus 1 power. And that is 8th power, 7 times 3 to the 8th. And that equals 45,927. So the 9th term is 45,927. We can see that geometric sequences increase rapidly. And you might have even heard that in language before, when someone says that the rate of growth is geometric. They're referring to this phenomenon. All right, in this example, the fourth term of a geometric sequence is 125, and the 10th term is 125 over 64. Find the 14th term. All right, this is obviously a harder one. I want you to take a moment to think about it and see if you can figure it out, because that's a good exercise for you. Pause. Definitely don't spend a lot of time on it. If you can't think of a strategy within, let's say, 2 minutes, then just resume and I'll get you started. But do try to find a strategy right now. Okay, this isn't necessarily the only way to do it, and maybe you even found another way, but this is one trick that you can use. And first of all, I'll just read the trick to you and then I'll explain it. What you do is you consider the fourth term your first and the 10th term your seventh. Then the 14th term will be the 11th. Okay, notice the pattern here. 4 minus 3 is 1, so fourth, first. 10 minus 3 is 7, so 10th, 7th. 14 minus 3 is 11, so 14th, 11th. Now, the reason this works is because with a geometric sequence, and really any sequence for that matter, it really doesn't matter where you start, because the ratio is always going to be the same, or the difference will always be the same. But since we're talking about geometric sequences today, we're going to talk about ratios. And if the ratio is always the same, well, then it's kind of like it was with those half-life problems. Remember, it doesn't matter when you start counting. You know that after the half-life goes by, you're going to have half of whatever you started with. Or for example, doubling. If you're doubling the amount of your investment, it doesn't matter what you start with. It's still going to take the same amount of time to double, no matter how much you start with. You start with $2, and it takes the same amount of time to double to 4 as it would to start with $200 and double to 400. It doesn't matter. All right, and to just really make that clear, I'm going to backtrack a tiny bit and show you something on a previous screen to explain why it doesn't matter what you consider your first term. And in this case, all that interests you is the 14th term. And so you can consider anything your first. Well, let's see why that's true. I'm quickly going back to this earlier example. Now, we already identified that this is a geometric sequence because it has a common ratio. And the common ratio is 2. All right, and we know our first term here is 3. But notice that if I consider my first term 3 here, well, then, of course, the 24 would be my fourth term. First, second, third, fourth. All right, but let's suppose that I considered 6 as my first term and kind of forgot about the 3 for a second. Well, in that case, if 6 is what I'm considering my first term, well, then my previously fourth term is, my previously fourth term is now my third, okay? Because it's 1, 2, 3, first, second, third. All right, so it doesn't matter because whatever you consider your first term or your 10th or your 20th, whatever you consider your starting point. Okay, the reason that it's relative and it's not absolutely important is because the common ratio is the same. And as long as you're consistent, you'll be fine. So if I consider this my first term, 3, well then 12 is my third term. But if I consider 12 my first term, let's just pretend I'm going to consider 12 my first term, well then 48 is my third term. Okay, and the reason it doesn't matter is because the common ratio is the same in either case, whether I start with 3 or I start with 12. The common ratio is still the same. Okay, so I'm going to go back to where we left off, and that was here. All right, so we are going to consider the fourth term our first, simply because that's the earliest term that I know. And to be consistent then, that would make the 10th term my 7th and the 14th term my 11th. And so if I find the 11th term when I'm considering the fourth term my first, then that will be equivalent to finding the 14th term if this fourth term is is where I start. Okay, so I know that this might sound confusing. This might be a case where it's going to be helpful to replay what I just said, think about it, but the main point is that all you have to do is be consistent, and it doesn't matter which term you consider your first, because the common ratio is always the same. Again, maybe you found another way, and that's okay, but this is a good way to get started. And what I'd like you to do now is, now that you've gotten started with this trick, see if you can figure out the rest. Pause the video, do it on your own, and then resume when you have an answer. Alright, so using the trick, a sub 1 is 125. Why? Because I'm given the fourth term, 125, and I'm considering the fourth term my first. And so my first term in this new way of looking at the sequence is 125. Well, this is my formula for the nth term. A sub n equals a sub 1 times r to the n minus 1. We know that already from previous screens. And now I just fill in what I can. 125 over 64, that's given to me in the problem. Now, it's given to me as my 10th term, but remember, I've now considered these terms differently. And so the 10th term now becomes the 7th. All right? If the fourth term has become the first, then the 10th term becomes the 7th. And that's why I have 7 as my subscript here. So 125 over 64 equals a sub 7. Then I just fill in the formula. 125 is my a sub 1. And then r to the 7 minus 1 power. And what I do then is I solve for r. Simply solve for r, and I find that r equals 1/2. And you can do that on your calculator. And then I want to get the answer. See, a sub 11 is my 11th term in this adjusted sequence. But the 11th term is equivalent to the 14th term in the unadjusted sequence. And remember, that's just because I've kept everything consistent. The 4th became my 1st, the 10th became my 7th, and so the 14th has now become the 11th. So a sub 11 in my adjusted sequence will be the same as a sub 14 in my unadjusted sequence. And it's the same value, and that's all I'm after. So a sub 11 equals 125, just filling in a sub 1, 125. 1/2 is what I found. That's my common ratio. And then 11 minus 1. And when I evaluate that, I get 0.12207. And that is the 14th term in the unadjusted sequence, which corresponds to the 11th term of the adjusted sequence. Here's the classwork. Page 669. Please write these problems down. And see you in class.